In this video, we're going to look at two-dimensional slices in Go. So the key difference in two-dimensional slices is you'll see the syntax here where we have two open and closed square brackets. And really this function create board highlights pretty much everything you need to know about two-dimensional slices. So when you want to make it, you specify you're making a two-dimensional slice, and you specify the number of rows if you're doing row major order, which is common. But then you have to actually build a slice in each of the slices, because what this is really saying is we have a slice of Booleans. So we make a slice of Booleans, and then each of those needs to be a slice of Booleans. So we've now built the two-dimensional thing. That actually means that it could be ragged. It could be the case that different rows have different number of columns. We're not doing this in this program, but that's possible. We're going to go ahead and just specify a width of 50 and a height of 20. Conway's Game of Life is a cute little animation. We initialize the board here, and you'll see that we're doing this loop. So row major order means that your y coordinate happens before your x coordinate as you view it on the screen. We're filling in the board if a random integer from 0 to 3 is 0, which means 25% of the cells are alive. We will set board yx to be true. So the way Conway's Game of Life works is a particular cell stays alive or becomes alive depending on how many neighbors are alive. So we have this count neighbors function that takes in the two-dimensional slice, and then the number of rows and columns. So, not the number of rows and columns, a particular location, right? So we're going to look at a particular location. We compute the number of rows and columns by the length of the two-dimensional slice and then the length of the first slice inside of that. We're going to loop from -1 to 1 is the change in y, and -1 to 1 is the change in x. That's going to give us 9 positions, including that center. The center we want to skip, that's not our neighbor, so we're not going to count it. The actual number we're looking at is x plus dx and y plus dy. We need to check and make sure we don't go outside the bounds of the slices. So we check to make sure nx is from 0 to columns -1, and then y is from 0 to rows -1. And then if that particular board location is true, we increment our counter, and then we return that count. So this is going to count for a particular location how many of the neighbors are alive. The next generation is going to take in an old board and a new board, which are two-dimensional slices. We loop through all of the rows and columns. We count the neighbors for each x and y. And then if we have 2 or 3 neighbors and we're alive, then we stay alive. If we have 3 neighbors and we're dead, then we become alive. And in all other cases, this next will end up being false, right? So if neighbors is 1, or neighbors is more than 3, or neighbors is 0, then this will be false. For neighbors being anything other than 3, this will be false. Printing the board, again, just loops through the slices. So here, we're going to get back the slice. We don't need an index. Here we're going to get back a particular cell, a Boolean. We don't need the index. And then we just simply will print out the filled in rectangle if it's alive and a space if it's not. As we look here at the main program, so in the main program we create 2 boards, one for the current generation, one for the next generation. We randomize the board, so we're going to fill in about 1/4 of the things. We're then going to loop up to the number of generations. We clear the screen. So this is just printing some ANSI characters that in most terminals will actually reset you back to the top and clear the screen. We print the generation, we print the board, we compute the next generation. This is a nice feature of Go. We can actually swap variables in a single line. And this avoids doing lots of copying because remember the slices only contain the dimensions and a pointer. So we're swapping the pointers. We're not copying all of the data from board to next board. And then we sleep for 350 milliseconds and do it all again. All right, so in order for you to see the animation, I've opened up another window here. And you can watch as you can see this is stable form. It got interfered with by another one, but we can make those little eyes. This eye stays stable until something else manages to get over there and interfere with it. So that's a quick introduction to 2D slices and Go with Conway's Game of Life.